Hello. Today we're going to use this circle and these angles to prove the angle difference formula for cosine. We need this sketch to show you that the angle that I've highlighted here, which is the angle formed by points A, O, and B, is equal to the angle formed here, which is the angle formed by points C, O, and D. So once we accept that those angles are the same, we're going to call that angle A minus B. And I think we can see that. This bigger angle is angle A, and this smaller angle is angle B. Angle AOC is equal to angle BOD. So angle COD is equal to angle A minus angle B. Okay, but is that equal to angle COD? In fact, it is. And so we can say that triangle AOD is congruent to triangle COD because we have a similar angle. We have the same angle, and they are isosceles triangles with the same side lengths. Okay, all of this is just to show that length AB is equal to length CD. So what we're going to do is we're going to use the fact that length AB is equal to length CD to derive a formula for the cosine of A minus B. So all of the preceding discussions just to show that length AB equals length CD. The meat of the derivation is using the distance formula to find two different ways to represent the same length. So CD equals AB. By the distance formula, CD equals the square root of the cosine of A minus B minus 1, that quantity squared, because those are the x terms, plus sine A minus B minus 0, that quantity squared, because those are the difference of the y terms, and the square root of that. That's the distance formula. Using the distance formula with points A and B, you get the distance AB equals the cosine of A minus the cosine of B, that quantity squared, because that's the distance of the x points squared, and then the sine of A minus the sine of B, that quantity squared, because that's the difference of the y coordinates, and that's the distance formula. So you take the square root of all of that. They're equal because we already established that segment AB and segment CD have the same length. It's kind of complicated looking at the square roots, so let's go ahead and square both sides to eliminate the square roots. All we did here was square both sides. We're allowed to do that because it's an equation. Next, we'll go ahead and expand those squares. On the left now I see cosine squared of A minus B and sine squared of A minus B. And when I add them together by the Pythagorean identity, I'm going to get 1. And on the right side, I see cosine squared of A, sine squared of A, cosine squared of B, and sine squared of B. And when I add those things together, I'm going to get 2. So let's simplify a little bit. See if we can clean it up. So let's make sure we see where everything came from. Cosine squared A minus B plus sine squared A minus B equals this 1 from the Pythagorean identity, minus 2 cosine A minus B, just pulls down from here. On the right side, cosine squared A plus cosine squared B equals this 1. Sine squared A plus sine squared B equals this 1. And we carry on with minus 2 cosine A cosine B, and minus 2 sine A sine B. I have an extra one here. I'll take that on now. So we can simplify a little bit. We can write this as two minus 2 cosine A minus B equals 2 minus 2 cosine A cosine B minus 2 sine A sine B. Subtract the 2's on both sides, and we get negative 2 cosine A minus B equals negative 2 cosine A cosine B minus 2 sine A sine B divide each side by 2, negative 2, and we finally get cosine of A minus B equals cosine A cosine B plus sine A sine B. Notice that the angle difference identity for cosine involves a plus sign in the middle. Cosine of the difference of A and B equals cosine of A times cosine of B plus sine of A times sine of B. And that's called the angle difference identity for cosine.